let's look at just finally in this section before we add more examples. I want to just go through the concept of outstanding balance and that little payment that's got to be made right at the very end of our system. Now, the outstanding balance, let's examine just theoretically first. Then we'll do a pile of examples that I've got over here. I just want to make a note, and I always say, start it there. Outstanding balances. Now, let us just look at a system. We have got, let us say, a monthly repayment. So we are paying X per month at interest equal to whatever it is. And let's say we're paying this over 10 years. Therefore, N is going to be equal to 120 monthly payments of X dollars, yen, pounds, euros, rands, whatever you like. Now, every month we're going to pay, so there's 120 of them. Let us now say that we get to the 7th year. All right. We get to year 7, and there is year 10 over there. Now, that was the old annuity. This was annuity 1. Now, let us say we get to the end of year 7. You can see the last payment is made at the end of that year. Now we say to ourselves, okay, we suddenly get a windfall of money, and we decide, which is always the best idea, is to pay off debt. So what do? I go to the bank and I say, how much do I owe you? What is my outstanding balance on this? Well, let's just wind this up a wee bit here and put in here we go, just over there. So this is already paid on the green side. Let's keep it as green. We have paid 7 times 12 payments. We have paid 84 payments of X, right? We've paid 84 payments of X. But on the blue side, we need to pay how many more? We need to pay another 36 payments of X. Thus, we've got the next payment is due there. We have now got 2 annuities. We have got the green annuity, which is the paid, and the blue, which is to pay. Now I go to the bank and I say, how much do I owe you? The bank will turn around to me and they will say, you owe me this annuity. You owe 36 times X. That's my installment, isn't it? So much a month. I owe that. I owe this. This is what I owe. How do I get it? I say, okay, then what is the present value of that annuity? Therefore, the present value of this annuity, I'll just do it over here, is going to be equal to X, which we know, and then it's going to be 1 minus 1 plus I to the power of minus N over I. This N here is going to be equal to 36 payments left to make. Because I'm working out how much I owe, I've got to pay the bank all of those. What's that worth today? It is worth that amount. So that is the outstanding balance. That is the outstanding balance. Let's look at an example of this outstanding balance problem. We have, okay, here's an example. Right? We borrow 100,000. We borrow 100,000. Over 10 years, at a rate of 10% per annum, and we say we compound that monthly. Right, what is my monthly repayment? Kiddos, what is my monthly repayment? What is my monthly installment? Simple. I just go to do my drawing, and I say, right, I borrow how much? 100, like so. And I say that is payable monthly over 10 years. Therefore, N is 120 payments, right? And 10 years at that, what is my monthly repayment? And I go and I work out X. Let's see. So therefore, I now know P is equal to X, 1 minus 1 plus I to the minus N all over I. So P I know is 100 is equal to X. I don't know the monthly repayment, 1 minus, and I say here 1 plus 0.1 divided by 12 to the power of minus 120 all over, I'm just going to move it up, all over 0.1 divided by 12. Therefore, I go and I calculate that, and I find that X is equal to 1321.51. 1321.51. That is what I am paying. So therefore, let's just do a check. I am paying 120 times 1321.51. So I pay, let's just do a quick check, 120 payments each month times 1321.51 is going to be equal to 158,581.20. That's just a quick check to see how much I have paid. Right, now I say to myself, now assume, okay, let's just go back. Part 2 of this is now assume we arrive at the end of year 7. Verse 7, what's the outstanding balance? The outstanding balance, what is it? Well, I say to myself, let's just examine it. I know that this is a bit of a pain in the butt. We said we owed here, we said we borrowed 100. We split that effectively up into X equal to 1321.51 over the period. Now I'm going to stop it at 7 and I'm going to continue here till 10. Where are we now? We are now over here. What do I owe? So let's have a look here. Green, I have paid. So far, I have paid 84 payments of 1321.51. We have paid that already. So therefore, let's go to our blue and we say, what is left over? Is this bit of the annuity here, which is going to be, I owe 36 left over. We owe 36 payments of 1321.51. We owe that. Therefore, the outstanding balance is, what is that value? It's P of today. The outstanding balance is going to be it's going to be the present value of that annuity, is it not? Let's see. So P is going to be equal to X. We're still paying 1321.51. and it's the present value, so it's 1 minus 1 plus 0.1 over 12 to the minus 36. There's 36 payments left, and that's over 0.1 divided by 12. Right? If I work that out, I get my outstanding balance of 40955.23 is outstanding. This is what we owe as of today. It's the present value of what's left to pay. So far, so good. Now, therefore, right, we could say that. That's the balance outstanding. There's another method which I will do at a later stage, where you take the total amount and less something else. But let's leave that. Okay, now let's go to the next part and say, now, say we have to skip 6 months. And the number of payments and the number of payments remains the same. Essentially, we have restructured the loan. Okay. So we got to this point here, right? Remember? This was all paid off. Let's put that now in the green. This was all paid. We paid the AT for. Then we found on the blue, we found the present value over there of 40955.23. Now we skipped 1, 2, 3, 4, 5, 6. Right? We skipped 6 months we didn't pay. Therefore, the first payment was 1, 2, 3, 4, 5, 6. The first payment came after 7 months, right? So now there's my standard annuity. And N left to pay, I've still got 36. I is still the same as it was before, which is our 0.1 or 10% per annum. I'm pretty sure that was what we said. Let's say, go back to the example, at 10% per annum. So that stays the same. We still owe 36. Oh dear, that made it very unneat. We still owe 36 payments, but I've now changed the game because I've now got to just change the color to red. I now have to get to here, because this is what we now owe this. This is now the actual value of the outstanding money. Because I owed 6 months ago, I owed 49.55. Now I've got to apply interest over that period. Therefore, we need to apply interest on 40955.23, because that's what we owed 6 months ago. So we've got to add interest onto that to get it to today, because where are we? We are here now. So therefore it's 1, 2, 3, 4, 5, 6 months. So therefore I use normal formula. Amount is equal to P1 plus I to the power of N, which is 40955.23 multiplied by 1 plus my interest was 0.1 over 12. Okay, was 0.1 over 12 for 6 months. In other words, we are saying 6 months of interest accrues. 6 months of interest accrues, isn't it? Because I can't say to the bank, I'm not going to pay you interest for that 6 months. I'm not paying them anything. Therefore, they have a right to charge me interest on that money. And my answer comes out then to be 43.43 046.13. Now this is what we have to pay. This is the amount that we have to pay the bank. Therefore, what can I do with that? I've now got a straightforward annuity that looks like this. I'll go back to black. I've got an annuity whose P value is 43046.13, and I'm going to split that up into N equals 36, I equals 10% compounded monthly, X is equal to, we don't know. We split that up as follows. We're then going to say, therefore, P is 43046.13 equal to X times 1 minus 1 plus 0.1 over 12 to the power of minus 36, all over 0.1 over 12, and you end up with X coming out to be 1388.98 per month. Straightforward. Okay, that's quite straightforward on that one. So what we've done is we took the skip. So can you see the timeline is critical here, guys? If you don't do the timeline, it gets confusing. You can't work this out in your heads or hold it all in your heads. And why should you? It's pretty pointless to do so. Okay, that's what a piece of paper is for, is it not? Okay, let's do another example of these. An example, we purchase a vehicle. We purchase a vehicle for 100,000. Okay, monthly repayment at a monthly repayment of 1,750 per month, with an interest rate of, and I is going to be 8% and compounded monthly. It's the same stuff, right? So calculate how long do we pay. 1, how long to pay off the loan. How long does it take to pay off the loan? Well, let's do our drawing. We borrowed 100K, and there's my, okay, and here I say X, I am given 1,750, N is what I don't know, and I for this one is going to be 0.08. So let's put it into the formula. We can say that P is going to be equal to, so I'm just going to write it down, is 100,000 equal to 1750, that's X, 1 minus 1 plus 0.08 divided by 12 to the power of minus N, all divided by 0.08 over 12. So far, so good. Okay, now if I calculate this, I get that multiplied across gives me 666.66 recurring, and is equal to, divided by 1750 is equal to 1 minus 151 over 150 to the minus N. Therefore, I'm going to take that across, and I get that that's going to be 666.66 recurring over 1750 minus 1 equal to minus 151 over 150 to the minus N. Okay. We've done these before. This is all a recap. Therefore, that is going to be minus 0.6190476 is equal to minus 151 over 150 to the minus N. Change sign and we get 0.6190476 equal to 151 over 150 to the minus N. Take logs on both sides. Therefore, the log of 0.61904 0.176 is equal to minus n times the log of 151 over 150. And I end up with basically just going to divide through by that. And we end up with n equal to, and you'll find your log comes negative and you change sign. So n is going to be equal to 72.175. 48767. Okay, like so. Now, what is my next port of call? My next is to then understand what is happening here. Okay. What are we saying? We are actually saying the following. We are saying that we have payment 71 and payment 72, all of 1750. Then technically, payment 73, we are short. It occurs 1750. It occurs at the 0.175 of a month. So it falls due before the pay date. Therefore, I say, right, I have got a little annuity left. It's this one. It's just that bit. So I need to work out what that P is at that point of the annuity with only one payment. So therefore, the balance, because we work to the month, the balance outstanding is P is equal to X 1750, 1 minus 1 plus I, which is 0.08 over 12, all to the minus 0.175, 48767. Do not round these off. It makes errors in a few of the little numbers right at the very end. Therefore, all that divided by 0.08 over 12. Because this little green thing here is the last payment of the annuity. It is the last payment of the annuity. And if I work that out, I get a value of 305.91. 305.91. Now, let's recap. Look, I've got it to there now. But when am I paying this? I'm paying this money there. This is paid 1 month later, which means I need to add another month of interest till you thought you got something for nothing, huh? Amount is equal to P1 plus I to the power of N, and I say that's A is going to be 305.91, 1 plus I, 0.08 over 12, and it's 1 month. I end up with 307.95 pounds, yen, dollars, whatever you like. Now, the last one is this one. Okay. Let's say here was, we take out a business loan of 700,000. Right? It's an example again. We take out a business loan of 700,000. And we make monthly repayments. And we make monthly repayments, installments in other words, monthly repayments at 12% per annum compounded monthly. The first payment is delayed by 4 months. Okay? And the term is 5 years. So I take out a loan today. This is now. And I am paid out 700,000 from the bank. But the first repayment is delayed for 4 months. So my annuity starts here with a term N of 5 times 12, 60 months of paying X, which we don't know. Right? We have no idea. We've got to work that out. But there's a delay. So I now have to say, I owe but look where it goes to. I was a bit quick there. It goes to there. Why? Because my standard annuity, this was my first payment. Therefore, my annuity says the P of it is at the point there. That is going to be the place that I want. So I have to apply interest for 1, 2, 3 months on what I borrowed. That becomes the present value of my annuity to be able to work out my repayments. So let's go back and work that out. I say let's put it in. So therefore the amount that I actually owe, that P value, is 700,000. 1 plus I is 0.12 over 12 to the power of 3 months, 725.75. That is that value there, is 772,725.75. It's quite a number. Okay. So now I say, all right, how much do I have to pay monthly to pay that back? That's quite a simple calc, isn't it? All I have to do is I put that in. I know my P is 772,725.75 is P. X, I don't know, 1 minus 1 plus 0.12 over over 12. Let me just 0.12 over 12 to the power of minus 60, all over 0.12 divided by 12. So therefore I can calculate that my X is 17188.86 per month for 60 months. Cool. So now I know what we're in for. But I made a change here. But now we decide to pay a flat rate of 17,000 per month and a last payment of less. What is the last payment? Okay, how do we work that out? So what have we got? We've done our thingy and we've said, right, now what have I got? I've still got this basic 750. That was delayed, remember? And it gave us a 772, just get the number again, 772,725.75. All right. Now we say X equals 17,000 now. Now we have to go and we have to work out N. I think you're getting the pattern here. I is still going to be 12% compounded monthly. Now I go and I work out N. This is that long one. I say 772,725.75 is equal to 17,000, 1 minus 1 plus 0.12 over 12 to the minus N, all that over 0.12 over 12. This I now need to work out. this I need to work out, and I come that in. I'm not going to go through the whole process. I'll just give you, basically, we get log of 0.54 5544 is equal to minus n times the log of 1.01. And you work out, and n comes out to be equal to 60.91598084. Let's go back and we say, okay, how do we interpret it? It means that I've got payment 59, payment 60, and there was 61. My actual payment is at 0.915988084 of the month, and that is my payment of 17,000. These were all 17,000 each. The last one isn't quite at the end of the month. It's at 0.915. Basically, it's due 0.915 times 30. It's due on day 27 and almost 28. So it's virtually at the end of the month. What do I do with this? I then say, right, I have to bring you back as an annuity. Therefore, I put you in and I say, to bring you back, P of that is 17,000 times 1 minus 1.01 to the minus 0.915988084. Correct? That's that number there. The little bit outstanding, 0.12 over 12. And I get that P is equal to, when I bring it back, I get P is equal to 15,423.94. So this is 15,423.94. This is my outstanding balance. Therefore, my last payment, the last payment is, add an in-month's interest, 15,423.94, 1 plus 0.12 over 12 to the 1. 1 month is 15,578.17 that I owe right at the end. I have gone 3 minutes over, so I apologize. But I've tried to do a few here so that we get into the handle of the outstanding balance and also the possibility of a single payment right at the end. Thanks for watching. I hope that it's cleared that up, and give it a go. Cheers. Bye.